Okay guys, this is part 2 for lesson 1. Last lesson, we identified the graphs of situations, so we did that matching activity towards the end. This lesson, we are going to look at learning goal number, I'll do this in green, I guess. Number 4 and number 5, identify and use variables to define independent and dependent quantities in real-world situations, real-world problems, And we're also going to write an equation to express a quantity that is the dependent variable in terms of another quantity, the independent variable. So the dependent variable always depends on the independent variable, and we're going to talk about that. And also, a quantity is a number. So we're going to have an independent variable that actually stands for something, a dependent variable that actually stands for something in real life, and then we're also going to have a number that represents that variable. So it's this learning goal right here and this learning goal right here. And I always have the kids look at these, so I always have them highlight them, go over them so that they can pick out their key information that they absolutely 100% need to know before they leave this class. Also, the key terms we're looking at today are dependent quantity, independent quantity. So those are the numbers that represent those independent and dependent variables. And also, of course, independent and dependent variables. The real world object that those represent. So we are going to actually go down to page 160, and we're going to just look at this little paragraph that the author wrote about this, and we're going to highlight the key information. So when one quantity depends on another in a real-world problem situation, it is said to be the dependent quantity. So that's the number. The quantity on which it depends is called the independent quantity. So the dependent variable, the dependent quantity, is going to depend on the independent quantity. It's pretty easy to remember. So the dependent quantity is going to change based off of what the independent quantity does. And remember, a quantity is just a number. It's an amount. The variable that represents the independent quantity is called the independent variable. And the variable that represents the dependent quantity is called the dependent variable. So just like the quantity, the independent variable does not depend on the dependent variable. The dependent variable will change every time the independent variable changes. So just like last lesson, we are not going to look at the pool party situation unless you want a challenge problem at the end. Then go for it. It is a good challenge problem. So let's try to deepen our knowledge of independent and dependent variables. Remembering that the independent variable does not depend on anything. The dependent variable completely depends on what happens to the independent variable. It changes based off the independent variable. So just like last time, your example is going to be with this fish tank problem, the fish tank scenario. And we went ahead and marked the text for that one on page 175, and we matched it up with graph F. If you just need a refresher, graph F was this right here. It was a constant rate, so it was a straight line, and it was draining, so the graph, if you read it from left to right, was going down. The water level was draining. So looking at this fish tank scenario, we already marked the text. So now we need to come up with our two variables. We have one that's independent and one that's dependent. So just a reminder, you are draining a 200-gallon fish tank at a rate of 10 gallons per minute. how much water remains in the tank at a specific time. So trying to figure out what your variables are is a little tricky. Usually, you see in this bracketed area, there's a reason we bracket that. There's a lot of information that comes from the bracketed area. It tells you what you're looking for. And being that it's telling you what you're looking for, that's where your two variables usually are. You can find your variables there. So if I were you, I'd pause the video and try to figure out what your two variables are going to be. We're going to have an X and we're going to have a Y. Remembering that a variable is just a letter that stands for something. So we're trying to figure out just right now what our two variables are. So our two variables for this situation is time. Time is our first variable. So it's asking for a specific at a specific time. So time is our first variable. Our second variable is the water that remains. So we'll just put amount of water. If this will write for me. I'm not good at writing with this pen yet. Okay, so we have time and amount of water. So we're going to go up and we are going to go back to page, we're just flip-flopping a little bit. It's a little easier on your book than my tablet. But we are going to go back up to page 160. And it says, what are the two quantities changing in this situation? We have time. And we also had amount of water. I'm going to write that off to the side. I don't have enough room. Okay, so those are our two quantities that are changing. Alright, and it says which one is the independent variable and which one's the dependent variable. So I'm going to highlight my independent variable just to save me time, because it's a lot harder for me to write on here than it is for you to write on your paper. My independent quantity, so my independent variable, my independent quantity is going to be highlighted in yellow, and my dependent is going to be highlighted in green out of the two we just wrote down. So thinking about which one depends on the other. So just take a second, I would pause the video and think which one of these depends on the other one. So let's start. I always like to start with the independent quantity. So time is always going to be an independent quantity because time does not really depend on much. There might be a few situations it will be dependent, but not very many. Time will continue going no matter what. It doesn't matter if it snows outside. It doesn't matter if you have a bad day. Yeah, it doesn't matter anything. Time continues going on. And so time is usually your independent quantity. It will keep on going no matter what. So that leaves our dependent quantity being the amount of water that was left in the tank. And it makes sense, the amount of water that was in the tank kept going down depending on how much time passed. So time did not depend on anything, and the amount of water depended on how much time passed. And that is the main thing that we're learning for this lesson. I want you to go ahead and skip C and D for now and go through all the different scenarios. So the rainy day scenario, the toy rocket scenario, the DVD and game rentals, the t-shirts. Go through those last four scenarios, and I want you to identify the independent and dependent quantities for those. And remember, independent and dependent quantities are the same as the variable. One is just the words it stands for, and the other one's just the numbers that they stand for. Okay, so go through, and just a reminder, for those 4 situations, they are on page 175 and 177. And, sorry, the last one is on page 179. So go through those 3, come up with the independent and dependent quantities for those on page 161. And then you just did learning goal number 3 and number 5. Sorry, number 4 and number 5. Thank you for watching.